Hello, second grade. I cannot wait to start something new with you today. We are going to really make those brains work, and we're going to start with a little warm up, and then we'll jump in and get busy. Let's go ahead and look at our learning target first. Let's pull back those bow and arrows, and I can subtract tens or 100s from a 3-digit number using place value. Now I have to tell you, second grade, today we really are going to use that value or that place to help us, and we're going to try to do as much of it in our heads as we can. You know, when we do our number talks, when we have our mental math where we just solve it in our head and not write it down on paper, I'm going to be encouraging you to do that today as we do our work, and then we're going to go back and we're going to use a model to help us prove it or check our work that we did right up here. So before we get started, I want to remind you, when we look at this learning target, it says we're going to subtract tens or 100s. That doesn't mean it's just a 10, right? So it could be 20, it could be 60, it could be 90, 100s could be 100, but they could also be 400 or 800. So it could be any of those hundreds. It might not be just a 10 or 100. It could be any of those others. It also says that we're subtracting it from a 3-digit number. Now, we were adding 3-digit numbers a couple weeks ago. Now we're going to be subtracting. And when we think about that 3-digit number, we want to remind ourselves that a 3-digit number, in fact, has 3 digits. It has a hundreds, a tens, and a ones. So it has a number in each of those places, so it is a 3-digit number. And we are going to use that place value. That means how much is that number in that hundreds place? How much is that number in that tens place? How much is that number in that ones place? And how can we use that to help us subtract today? Let's go ahead and start by looking at these 3 equations. What do you notice about these 3 equations? Ooh, they all have a 9 and a 1 in them. 9 and 1, 9 and 1, 9 and 1. What else do you notice about all of them? They are all subtracting. Anything else you notice? These 9 and 1s are in the ones place. Where are the 9 and 1s in this one? They're in the tens place. And what about that equation down there? Yes, that 9 and 1 is in the hundreds place. How could we use this to help us solve those? So we know 9 and 1 equals 8. So if we know 9 and 1, 9 take away 1 equals 8, what would 90 take away 1 be? Right? So if we know that 9 take away 1 is 8, then 9 tens take away 1 10 equals 8 tens. And what is 8 tens worth? Yes, it's worth 80. Oh, look at there. 8, 80, 8 in the tens place. What about our hundreds? Right, that's like saying 9 hundreds take away 100 equals 8 hundreds. And how do we write 8 hundreds? Yes, if there's 8 hundreds, that means that is worth 800. So when we look at this, we can use this to help us solve this and this. What place changed in this problem? Why did the tens place change? Because you were taking 1 10 away. Did the ones place change? Why not? Right, there's a 0 in that ones place. So if there's a 0 in it, that ones place isn't going to change. What place changed when we were subtracting 900 minus 100? The hundreds place. And why the hundreds but not the tens or the ones? There was a 1 in the hundreds place, but not in the tens or the ones place. There were 2 zeros in the tens and the ones. And so that tens and ones place didn't change. I want you to use that piece of information. And I want us to remember that as we go ahead and start solving some more problems. Now you can see we've got a lot on our plate today, right? We have 3 different launches. Now, with each of these, I want you to do them in your heads mentally first. And then I want you to double check it with your base 10 blocks. Let me show you what I mean. If my first one says, what is 100 less than 512? Well, 100 means that my hundreds place will change, but my tens and my ones won't, like this one, right? So when I look at 512, I see that 5 is in the hundreds place. So 1 less than 5 or 100 less than 500 is 400. But my tens place, my 1 in the tens place won't change. And my 2 in the ones my 1 in the tens place won't change. And my 2 in my ones place won't change. So I think that 412 is my answer. But now I'm going to double check it. So I'm going to draw my 512, 500s, 110, and 2 ones. And now I'm going to take away 100 because it's 100 less, right? And when I do that, I have 400. I still have 110. And I still have 2 ones. And that makes 412. I'm right. Now I want you to do the same thing with the next 3. I want you to do it in your head first, just like I showed you. I looked at my hundreds place because that's what it was asking me, and I changed that one. I want you to do the same thing on yours right now. Go ahead. I might be asking you to where your work is in your model. Let's go ahead and get started. What place is going to change? Why is it the hundreds place is going to change? And what number is in the hundreds place? How would you show that in your model? And remember, second grade, you're going to do all 3 of these. So we're not going to stop with each one. I'm going to ask somebody to share their thinking for each of these when we come back together. So when I'm asking you to solve, don't just stop with this one. I want you to do each of these for our first problem. When you're showing 386, how many hundreds are you going to have? And so how do you show 100 less than that? Will your 8 and your 6 change? How can you show that in your model? With 888, there's 3 8s. How much are those 8s worth? How much is the 8 worth in this problem? Or in this place? How do you know it's worth 800? Because it's in the hundreds place. Okay, what about this 8 in the tens place? It's worth 80. There's that place value, right? And then what about this 8 in the ones place? How much is it worth? So which of these 8s is going to change if you're finding 100 less? How do you know? All right, friends, coming together in 5, 4, 3, 2, 1, and pencils down. Done. If you are at home and you need to pause me so that you can finish, you're welcome to do that. We're going to come together and show what we know. Talk to me about 100 less than 437. What did you think about in your head? Okay, your 4 is in the hundreds place. And why did you underline the hundreds place? Because you were finding 100 less. All right, and when you showed 100 less, what did you think in your head? 1 less than 4 is 3. Okay, so 4 take away 1 is 3. So you have 3 hundreds Why does your 3 in your tens place and your 7 in your ones place not change? Because there's zeros in that 100. And so when you showed your model, what did you do to show that? Okay, you drew your 400, 10, 20, 30, 1, 2, 3, 4, 5, 6, and 7. All right, and what did you do? You took away 100, okay? And when you did that, what did you have left? 300. You still have 3 tens or 30, and you still have 7 ones. Did your model help you prove your mental math? Yes, I'm seeing some wiggle waggles. All right, what about 100 less than 386? What place were you looking at? Why your 100s place? Because this says 100 less. And which digit or which number is in your hundreds place? Your 386. And so what did you do in your brain? All right, so 300s. Take away 100 is 200. All right, and then you had 86. And how did your model help you prove it? 300s, 10, 20, 30, 40, 50, 60, 70, 80. 1, 2, 3, 4, 5, 6. All right, and then what did you find? You had to take away 100. Did you take away any tens or any ones? Why not? Because you had a 0 in the tens and a 0 in the ones place. And so you had 200s, 80, so 8 tens, and 6 ones. Did you? Yes, your model helped you prove it. What about this one? There's 3 8s. Aren't they the same? Which 8 is changing? Why the first one? Because it's in the hundreds place. 800, 8 tens, 8 ones. And so which one's going to change? All right, and what's it going to change to? Why 7? Because that's going to stay the same, and 8 take away 1 is 7. All right. Do we need to show that at this point? I don't think so. All right. Same kind of work, my friends. This time we have 4 to solve. I'm not going to do the first one for you because I showed that first one up here. Same thing's going to work, though. You're going to do it in your head first, like all of our friends did, and then prove it with a model. And we'll only choose a couple to prove with a model so we can start seeing these patterns, okay? So we have 512 take away 10, 437 take away 10, 704 take away 10, and 386 take away 10. I'm going to go ahead and give you a few moments to solve these and show your thinking, or check your thinking, I should say. And then we'll come together and show what we know. What place is changing this time? Why is your tens place changing? Okay, so what is going to happen to your hundreds and your ones? Why are they going to stay the same? Okay, so when we look at this one, we only have a 10 changing. There's 0 ones, and there's nothing in the tens place, all right? So how would you prove that with your model? What are you going to cross off with your model? One of those sticks of 10. All right, you're already at 704 take away 10. Talk to me about what you're thinking with this one. Why is your hundreds place changing? I don't see anything in the hundreds place there. Oh, because there's 0 tens left? Ah. So it's almost like you have 70 tens and you're taking away a 10. So when you have 70 tens, what are you taking away? 1 10 from that. And what's 1 less than 70? 69. And how does that look in your work when you double check your work? All right, friends, let's come together. Remember, if you're on your own at home, pause me and resume it when you're done doing the work for all of these. Let's go ahead and look at that first one. What did you say, my friend? Okay, why did you say 502? Okay, so there's nothing in your hundreds place. There's a 1 in your tens place, and a 0 in your ones, and a 1 in your tens place, and a 0 right here in your ones place. And so you're taking what? 1 take away 1 equals 0. All right, and so when you show that, 10, 20, 100, 200, 300, 400, 500, 110, and 2 ones. And then what part of your model are you taking away? Your tens place. And there we go. Now we have 0 tens left. We still have 2 ones, and we still have 5 hundreds. Very nice work. What about this one? 437, take away 10. Your hundreds place is staying the same because there's no hundreds. What about the tens place? 3 take away 1 equals 2. So 3 tens take away 1 10 equals 2 tens. What about your ones place? Why 7? Because 7 take away 0 is 7. All right. Let's prove it. Or check it, I should say. 2, 3, 4, 5, 6, and 7. These numbers look familiar, don't they? Yes. All right, and what are we taking away? 110. And we still have 4 hundreds, 2 tens, and 7 ones. 4 hundreds, 2 tens, 7 ones. What about 704? Somebody when I came to somebody, what did you say? 700 is like 70 tens, and you're taking away 1 10 from 70 tens. So what does that leave you with? 69 tens. So then you have 69 tens, and then you say your ones place is staying the same. How did you check that with your work, with your models? You still drew 700s. 1, 2, 3, 4, 5, 6, 7. You had 0 tens, and you had 4 ones. Why did you leave a space? Okay, so you crossed off 100, and you did 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Do you still have 704? 100, 200, 300, 400, 500, 600. 600, help me count. 610, 620, 630, 640, 650, 660, 670, 680, 690, 700, and then we have 704. All right, so when you take away one of those tens, what do you find? We've got those 600s. Now we have 9 because 10 take away 1 equals 9, and we still have those 4 ones. So in this case, our hundreds place changed too, because there were 0 tens to take away, right? So we didn't have any tens to take away. We had to jump into those hundreds. What about 386? Okay, your hundreds stayed the same. What about your tens? 8 take away 1 is 7. 6 take away 0 is still 6. Holy schmoly. All right, friends, at the beginning with our learning target, it said I can subtract tens or 100s from those 3-digit numbers using place value. So we warmed up with just 100 and just 10, but now I want you to look and see. Now, our ones still have those zeros in there, right? But now you have some more hundreds or some more tens to take away. Go ahead, do some solving on your own. Again, I want you to see what you can do in your head, mental math, and then you can prove it with your base 10 models. Go ahead and you may begin to solve. Make sure you ask yourself while you're working, what place is changing? How much is it changing by? What place is going to stay the same? And why? I want you to pause your video to give you time to work, and then I want you to play it again so that you can follow along as I show this thinking. So pause me now and resume me when you have solved each of these 4 problems. All right, now that we're coming back together, let's think about these numbers. 597 take away 220. What did you do first when you were solving this problem? Okay, you knew that 500 take away 200 equals what? 300. Okay, then what? 9 tens. Take away 2 tens equals what? 7 tens. And then what else did you notice? Why is your ones place going to stay the same? Because there are 0. So let's work it out. What do we notice? 500s, 10, 20, 30, 40, 50, 60, 70, 80, 90, 9 tens, and then we have our 7 ones. So when you're taking away 200, what are you doing? 100, 200. Do you still have 300 left over? Yep. What about your tens? 10, 20. What do you have left over? 1, 2, 3, 4, 5, 6, 7 tens. And then we have our 0 ones. So we still have 300s, 7 tens, and 7 ones. All right. What if we have 597 again, and now we're taking away 450? 5 take away 4 is 1. 9 take away 5 is 4. And we still have that 7. Right. Even if we were to show that in our base 10 blocks, we're saying 500, 30, 40, 50, 60, 70, 80, 90, and 7 again. Because we're starting with that same number for each of these. This time we're taking away 4 tens. It's 400s, and I have 1 left. We're taking away 5 tens this time, and I have 4 tens left, and our ones stay the same. What about these 2? 5 take away 3 is 2. 9 take away 1 is 8. 7 take away 0 is 7. And what about this last one, my friends? Ooh, what do you notice? 5 take away 5 is 0. So are we going to put anything in that hundreds place? No. What about your tens? 9 take away 6 equals 3. And there was that 7 take away 0 equals 7. So 597 take away 560. This is with a 2-digit number left. Second grade, you have some practice problems to do. Remember, a lot of this today is in your heads first, and then check it with your base 10 models. I can't wait to see how you do this mental math. Happy solving!